for billions today. The beginning of Ramadan is announced with a simple phrase: the moon has been sighted. But what if I told you it was never that simple? Long before satellites, telescopes, and space agencies, early Muslim astronomers were calculating the moon's movement with astonishing precision. They built observatories. They mapped the heavens. They measured celestial mechanics with mathematical brilliance. Ramadan was not just a spiritual event. It was a cosmic calculation. Tonight, we uncover the forgotten scientific revolution that ensured Ramadan began, not by guesswork, but by mastery of the skies. Islam follows a lunar calendar. Unlike the solar Gregorian system, Islamic months begin with the sighting of the new crescent moon. That sounds simple. Look up. See the crescent. Start. Day. Month. But here's the problem. The moon's visibility depends on atmospheric clarity, geographic location, and precise angular separation from the sun. A crescent can exist astronomically, yet remain invisible to the human eye. For a global faith, this posed a serious challenge. Ramadan is not symbolic timing, it is legally binding. Fasting must begin at the correct moment. So early Muslim scholars faced a profound question. How do you ensure religious precision in a world without modern technology? The answer lay in science. During the Islamic Golden Age, roughly 8th to 14th centuries, astronomy flourished across the Muslim world. Centers of learning in Baghdad, Damascus, Cairo, and Cordoba became hubs of celestial research. Astronomy was not just academic curiosity, it was a religious necessity. Prayer times depended on the sun's position. The direction of Mecca required geographic calculation, and Ramadan required accurate lunar tracking. Scholars translated and expanded upon Greek, Persian, and Indian astronomical works, but they did not merely preserve knowledge, they advanced it. They refined planetary models, improved mathematical tools, corrected earlier calculations. Ramadan demanded precision, and precision fueled innovation. Early Muslim astronomers constructed some of the world's most advanced observatories. In the 9th century, the Abbasid Caliphate funded large-scale astronomical research in Baghdad. Later, monumental observatories were built in places like Maragha and Samarkand. These were not small rooftop platforms. They were scientific institutions, equipped with massive quadrants, astrolabes, armillary spheres, and mural sextants. Instruments capable of measuring celestial angles with incredible accuracy. Astronomers tracked lunar phases, calculated conjunctions, and predicted visibility windows. They compiled detailed astronomical tables known as Zij. These tables allowed scholars to forecast when and where the crescent moon would likely be visible. This was not guesswork. It was predictive science, and Ramadan depended on it. To determine the start of Ramadan, astronomers needed to calculate the moment of lunar conjunction, the moon's altitude above the horizon, the angular separation from the sun, the age of the moon at sunset. If the crescent was too close to the sun, it would disappear in glare. If too low on the horizon, it would set before being visible. This required geometry, trigonometry, and spherical astronomy. Scholars like al-Battani and al-Biruni refined lunar motion models centuries before European advancements. They corrected errors in earlier Greek astronomy and improved calculations of the lunar month's length, approximately 29.53 days. Even a small miscalculation could shift Ramadan's start, so accuracy mattered deeply. Religion and science were not in opposition. They were intertwined. Here is what makes this story remarkable. Ramadan is observed worldwide, from Morocco to Indonesia, from Nigeria to Turkey, from America to Malaysia. But the moon appears differently depending on location. Without precise calculation, communities would constantly disagree. Astronomical knowledge allowed scholars to anticipate these differences. It helped unify large regions under consistent rulings. Some jurists insisted on physical sighting. Others allowed calculated prediction when accuracy was established. This debate continues today, but what cannot be denied is this. Early Muslim astronomers laid the groundwork for global religious. They transformed lunar observation into a disciplined science. There is a common assumption that advanced astronomy is a modern achievement, but centuries ago, without telescopes as we know them today, Muslim scholars were measuring the heavens with astonishing sophistication. Their observatories influenced later European Renaissance astronomy. Their star catalogs improved navigation. Their lunar calculations shaped religious life for generations. And at the heart of this scientific pursuit was Ramadan, a spiritual month that required cosmic precision. The start of fasting, the night of Laylat al-Qadr, the celebration of Eid, all depended on the moon, and the moon demanded mastery. So perhaps Ramadan is not just about hunger and prayer. It is about alignment with time, with celestial rhythm. With the orbit of a moon circling 384,000 kilometers above Earth, each year, believers wait for the crescent. But behind that moment lies centuries of observation, mathematics, and intellectual brilliance. Faith inspired science. Science preserved faith. The sky became both a sign of God and a field of study. Ramadan was never guesswork. It was cosmic discipline. The next time you hear that, Ramadan begins with the sighting of the moon. Remember, that sighting carries centuries of calculation, of observatories, of scholars, of celestial mastery. The story of Ramadan is written not only in scripture, but in the stars.